Hi guys, let's see today's question. So today's question, if you see, is a quadratic equation which is having complex coefficients with it. Let's understand how to solve this question. So you will be already knowing that whenever there is a quadratic equation, and if you want to find the value of the roots of this quadratic equation, what we do is we follow that Sridhar Acharya's rule that says minus b plus minus square root of b square minus 4ac upon 2a. So this, if you solve, you get the value of roots of this quadratic equation. So from the above equation which is given, if I just compare that equation with ax square plus bx plus c equals to 0, what I get here is a is 2 plus I, b is minus in the bracket 5 minus I, and C is 2 into 1 minus, right? So if I further want to solve it, first let's see and understand this part, that is b square minus 4ac. So if I first solve only that much part, that gives me b square minus 4ac is equal to b square means square of a negative number, we know it is always positive, so minus ka square will become positive, so I'm left with 5 minus I the whole square minus 4. A is 2 plus I, C is 2 into 1 minus. So if I square it, it becomes A minus B the whole square, A square minus 2AB plus B square. So A square minus 2 into A into B. So 2 into 5 is 10, 10 into I is I, so 10I plus B square. So B square is I square minus 4 into 2 is 8. And if I multiply those two brackets, what I get is 2 into 1 minus I is 2 minus 2I plus I into 1 is I and minus I square. I square, so that gives me minus I square. Okay. So 5 square is 25 minus 10I plus I square. Everyone knows from the complex numbers that I is what? Square root of minus 1. So I square becomes minus 1. So I square, it is minus 1 minus 8. This becomes 2 minus 2I plus I is minus I and minus I square. So this is again minus 1. So minus into minus 1 is plus 1. Here if you see 25 minus 10I minus 1 minus 8 into 2 plus 1 is 3 and minus I. So now that gives you 25 minus 1, that is 24, and 24 minus 10I minus 24 plus 8. So 24 and 24 gets cancelled. I get minus 10I plus 8I. That gives me minus 2I. Okay. Let's understand it further. Now here, if we apply that formula which we already know, x is minus b plus minus square root of b square minus 4ac upon 2 into a. So we already know b was minus of 5 minus I. So if you see, minus of minus will make it plus, so it becomes 5 minus I plus minus b square minus 4ac. We already got that as minus 2I, and 2 into a, where a here is 2 plus I. So I'll write that 2 times 2 plus I. So let's first find square root of minus 2I. Whatever you get as square root of minus 2I, we'll substitute it here and then we'll get the roots of this question. So first of all, let's find what is the square root of minus 2I. So if you understand, square root of a negative number, that is also a complex number. So square root of a negative complex number will already become a complex number. So we know that we represent a complex number by a plus ib. So let's say that square root of this complex number is some complex number a plus ib. So if I square both of the sides, on the left hand side we are left with minus 2i. On the right hand side we are left with a plus ib the whole square. Now that tells me it becomes a square plus 2aib plus ib the whole square. Now that gives me a square plus 2abi, and this becomes I square b square. I square is minus 1, so it becomes minus b square. This is minus 2i. Now here when I have minus 2i, I don't have the real part of this complex number as anything, so I can write it as 0 minus 2i. So here if you see 0 minus 2i, it's equal to a square minus b square plus 2abi. So if you see, this is the real part here, this is the real part here. So if I equate them, I get a square minus b square is 0. And if I equate the imaginary parts here with I get 2ab is minus 2. So ab becomes minus 1. So what I understand here is that the product of the two terms should turn out minus 1, and a square minus b square should make it 0. So I can take a as 1, b as minus 1. The product of them will become minus 1, and the square of the difference will turn out 0. Or you can also take it as a is minus 1 and b is 1. That will also make this minus 1 or a square minus b square as 0. So what I get here is that root of minus 2i, I can write it as 1 plus minus 1 into I. That makes it 1 minus I. Or I can also write root of minus 2i here as minus 1 plus 1 into. So it makes it minus 1. So I'm getting two roots for this equation. Now let's find out. If I substitute this, I get root of minus 2i as 1 minus I, or I get it as minus 1 plus I. So now here if I put that, I'll take both of them and understand. First we will see root of minus 2i. I'll put it as 1 minus I. Let's understand what we get here. And root of minus 2i, if I put it as minus 1 plus. So now first if I put, that's equal to 5 minus I plus minus. Here instead of root of minus 2i, I'll put that as 1 minus I upon 2. What you get here is, if I first consider only the plus sign, it makes it 5 plus 1 6, and minus I minus 2i upon 2 into 2 plus I. Or if I take now minus sign, let's see. So if I take minus sign, 5 minus 1 makes it 4, and minus I plus I gets cancelled, right? So 4 upon 2 into 2 plus I. So this is one expression. Now let's put this and understand what answers do we get here when you put this. So again, if I write the same expression, x is now 5 minus I plus minus, now I'm putting minus 1 plus I upon 2 into 2. Actually, if you see, it does not make any difference. You will get the same two terms, but the order in which you get them. So if I put, first of all, let's say plus, 5 minus 1 will turn out 4, minus I plus I will become 0. So you get 4 upon 2 into 2 plus I. Or if I now take it as minus, so 5 minus minus 1, so 6, and minus I minus I minus 2. So again, if you see, with both of these options, we are getting the same two terms. So now if you want to solve this ahead, and then you will get the answer for these roots. So x can be 6 minus 2i upon 2 into 2 plus I. So we already know that we do not need a complex number in the denominator. So what we will do is we'll multiply by its conjugate. So I'll multiply both sides by 2 minus I. this gives me 6 minus 2i into 2 minus I. So that if I here from here if I take 2 also common, I'm left with 3 minus I into 2 minus I upon 2. A plus b into a minus b gives you a square minus b square. So a square, that is 4, minus b square, so minus I square. So 2 gets cancelled. What you're left with here is 3 minus I into 2 minus I, that is 6 minus 3i minus 2i, so minus 5i, and plus I square will give you minus 1 upon 4 and minus I square. So I square is minus 1, so minus into minus 1 is plus 1. So this gives you 5 minus 5i upon 5. 5 I'll take out common, 1 minus I upon 5 gets cancelled, so you get one root of the equation as 1 minus I. So that is your first root of the question which was asked. Now if you solve this also further, solve it on the next page. So that gives you x is equal to 4 upon 2 into 2 plus I. So I can just cancel out this. So it becomes 2 upon 2 plus I. And if I multiply both sides by 2 minus I here only, get it as 2 into 2 minus I becomes 4 minus 2i upon a plus b into a minus b becomes again a square minus b square. So 4 minus I square is minus 1, that gives me minus of minus 1 plus 1, so becomes 4 minus 2i upon 5, that gives me 4 by 5 minus 2 by 5. So that is my second root of the quadratic equation. So let's understand what were the roots. The first root was 1 minus I, and second root of this given question was 4 by 5 minus 2 by 5. So this is how you solve this type of questions which involve complex coefficients in a quadratic equation. I hope you understood this. Also, do let me know if you have any more questions where you have doubts in, so I'll take them again. Thank you.